Hello, everybody. Welcome back to a new episode of the Midnight session. Just wanted to confirm if everybody can see my screen, they can hear me well. Sometimes Discords it can act weird. We got you. Perfect. Hello, James. What's up, everybody? You can hear me, right? You can see my screen. All good? Yeah, perfect. Yes, all good. Perfect, perfect. Thank you, guys. Okay, so let's start. For these episodes, we're gonna talk a lot about different things regarding the ecosystem. We're gonna go through some blogs, Dev Diaries, Academy, hackathons, catalogs. Regarding code, we're gonna keep talking about some API functions, and we're gonna start looking at the TUI interface. And then we're gonna open the mics so people can jump into the stage and ask questions, or just write your questions on the chat window. Okay, so let's start with the blog. Uh, the Midnight team they just posted a new information regarding the second and third phase of the distribution process, which is called the Scavenger Mine and beyond. So let's take a look at this blog. So they published this blog and they gave more information regarding this scavenger mine. So the main idea of this glacier drop process is to be fair. They want the midnight token night to be distributed fairly and to get to the more people possible. So the first phase, there is a prerequisite. There is a snapshot. So you needed to have some tokens before this snapshot, and then to actually hold more of $100,000. No, sorry, $100 regarding that token. So only that people qualified to actually claim some of the night tokens, but they wanted to be even more uh, inclusive. So they created these other two phases, phase two and phase three. The scavenger mine, it's a process that everybody can participate. You you didn't even need to hold some specific tokens during the snapshot or nothing. Everybody can jump in. Even for new people joining the ecosystem, learning how to use blockchain, they can participate on this phase two, the scavenger mine. Previously, the Midnight team didn't provide any information regarding that phase, but now they gave a little bit of more information about that, and I wanted to share it with you all. So, how this is gonna work? They mentioned here that this phase is gonna happen during a 30-day scavenger mine period. That is gonna be divided in 30 equally daily portions, uh, and rewards allocated at the end of each 24 slot. So after phase one, the glacier drop, whatever funds are uh, remaining, because according to the past, I mean, there's not that much people that actually claim their airdrops. So whatever is left from this phase one, it's gonna get into the scavenger phase. That amount is gonna be divided in 30 pieces, where each piece, which is 1 day, is going to be rewarded following this procedure. Here says each puzzle or task completed will assign a proportion of the unallocated tokens to the participant that completes the computational task or puzzle, the reserve, which is managed by smart contracts and controlled by the network protocol, the Midnight Foundation and TGE, the token generation event, which are responsible for growing the Midnight network and acting as catalyst for building and wider adoption, and the on-chain treasury, which is a pool of tokens reserved for ecosystem development. So let's put an example so we can better understand how this is going to work. We have some funds remaining. This is going to be divided in 30 days. And within 1 day, there's gonna be miners trying to solve these puzzles. How many miners? We don't know. It's gonna depend on how many people are actually interacting in this phase. Those that actually solve this puzzle, they're gonna get rewards based on that amount allocated for that day and the number of miners that participated during that day. And that amount is gonna be divided between those miners and these midnight, sorry, and these midnight stakeholders, the reserve, the Mina Foundation, and the on-chain treasury. Something that they mention is that this process is going to be set up in a way that they don't favor uh, professional miners. So you're not going to need like a really high end GPU or something like that. With your computer, a CPU, you can actually solve those puzzles and get rewarded. So this is something really nice that the Midnight team is doing to actually be more inclusive. So everybody's going to be able to participate and get a portion of this scavenger phase. Then there's going to be also a third phase, which is the lost and found. This phase, it's for those that qualify during the glacier drop, but for some reason didn't claim the rewards. So whatever it's lost, right? That's why this name, lost and found. Whatever remains from these two phases, these people are going to be able to actually claim those lost and founds, right? Of course, it's not going to be the 100% of the allocations during the glacier drop, but it's still they're going to get a percentage of whatever it's remain. Yeah, so that's regarding the scavenger mine. Uh, One thing that they haven't released yet, it's the percentages, right? Uh, the percentage allocated to this phase two, there's not going to be any percentage at all because it depends on how many people actually claim during phase one. But the percentage that they might, they will deliver in the future, it's from those proportions, from those allocations within one day. How many tokens are going to participants, how many are going to the reserve, how many are going to the Meta Foundation and to the on-chain treasury, right? So yeah, this process is going to be really really nice to actually participate, and I'm myself going to for sure participate during this scavenger mine phase. Okay, now let's jump into one of the Dev Diaries. This episode, we're going to talk about a process in Compact. The idea of the sessions is that we are starting uh, at the beginning, really in a really basic concepts, gathering all different concepts regarding compact and libraries and instances, and the end goal is to actually build an application. But in the process, we might jump into some specific features within compact so we can get a grasp of what's going on within compact. So this time we are going to explore some more advanced features within compact and understand them, right? So let's jump to this diary. So we are going to explore now this diary from Claude Bart, which is one of the teams of the DevRel division of Midnight, and it's about simulating a division in Compact. So if we go to the Compact reference of Compact, we can see here that there is all the specification regarding Compact. We are going to study all this stuff together. But this time, I just wanted to show one of the features within Compact. It's regarding operations. Let me find it here. Um, yeah, it's a lot of information, but let's just focus now in this specific here. So one of the expressions and operations available in Compact, it's we can add, we can subtract, and we can multiply, but there is no division. yet. In the future, the Midnight team it's considering on adding this division operation. But right now, if we want to implement that, there is two ways that we can actually do that. So this diary explains the way to actually implement division in Compact. So according to Claude, he proposed two solutions for actually accomplish this division operation. One, it's implemented 100% within Compact, and the other, it's a more recommended way to actually do the division, but it involves using off-chain computation. So this off-chain computation is something that we can implement within Compact using witnesses. So let's take a look. Let's first study the first solution regarding implementing that operation 100% using Compact features. So in this case, we are creating this struct. This struct is like a type, a custom type in TypeScript, but in Compact, right? So we use struct, and we are creating this type called div result. There is a quotient of this type, uint 128, and a remainder of uint 128. This uint, it's a normal integer that we know in TypeScript, and we have this number of bits. Okay, now we are defining a circuit. As we studied before, in Compact, a function, we call it a circuit, because in Compact itself, it behaves like a normal function, but the Compact, what it does when it compiles, it actually creates all the cryptographic materials and to actually have a circuit, right? Because we're using zero knowledge. So this circuit function uh, is gonna be pure, meaning we're not gonna talk with the state, the ledger state, or any witness at all. So that's why it's pure. We're gonna have these arguments: a dividend, a divisor, and a div loop. And what this logic is doing, it's we are asserting first that the divisor is different than zero. Otherwise, it's gonna fail and it's gonna give this log division by zero. And then we are using this operand fault. So fault, it's a high level operator for working with vectors. So in Compact, we don't have undefined vectors. We have to define, if we want to iterate on something, we have to say to Compact, we want to iterate on these specific boundaries. We cannot just give unbounded information. So in this case, we're passing a vector of 1000. And what we are doing, it's actually, if you see here the logic, we are subtracting the remaining minus the divisor, and we're incrementing the counter. So the way this is working, it's actually subtracting the divisor and getting a remaining, and just iterating on this process until the remaining is less than the divisor. Means there is no, we have already subtracted everything that we can. And the counter, it acts like the quotient. So in that way, we have the divisor, right? This is nice. It's everything implemented within Compact, but there is trade-off. The first one, if you see here, we are saying, okay, we want to iterate 1000 of times, 1000 times. If this iteration, it's a small number, let's call it 10 times before getting the answer, we are still gonna iterate 1000 times. Now let's say, okay, I want the iteration to be faster, and this vector is gonna be 10 now. I don't want 1000, I want 10. If I give a bigger number to actually get the division from, this is gonna fail because I'm not gonna have enough iterations to actually subtract the divisor from the dividend, right? So that's a trade-off. We need to know in advance how many iterations we're gonna need to subtract. And something that we don't want to do in Compact, it's perform huge iterations. Otherwise, the circuits are gonna be really expensive. Something that we want is to have really lightweight circuits, so the process of proving and verifying that proof, it actually happens really fast. So this was provided just for reference, but according to the author, Claude, the recommended way is to actually perform off-chain computation. So he gives the solution using witnesses. Witness in compact and connecting it to circuits, it's information that we use to compute something, but using circuits and zero knowledge proof, we're gonna be able to demonstrate that that computation was done using that private information without disclosing that private information. So this witness, it can actually get information from a private storage, or actually can implement some computation, and the result can be imported into the compact itself. So this is what we're doing right now. The division are going to be performed off chain using TypeScript, for example, in your computers, and the results are going to be imported back into compact. So let's take a look how this was implemented. So now we call a circuit function called checkDiv. We pass again the dividend and the divisor, and then I'm calling div mode. This div mode, it's actually a witness. So we are passing these arguments and we are returning the result. This div mode, it's actually implemented off chain in our computers. So we are just getting the result. One question would be, okay, how do I know that that result is true and not a hacker? It's kind of implementing something that I cannot prove of. So we can, the way this function is being implemented, it's performing a computation off chain using witnesses, and then asserting the result within compact. So really nice, right? Doing a computation of chain and then proving the results within the compact itself circuit. So after performing this computation, div mode, we get the result. And now within the circuit itself, we can assert the result. First, we see if the remainder is less than the divisor, otherwise it fails. And then proving that the quotient times the divisor plus the remainder, it's the dividend. So we have multiplication in compact. So knowing the result, we can multiply it and prove that the result is okay. So we are doing that. And in that way, we return true if it passes. So in that way, we created a off-chain computation and we prove the results within compact. Really nice. And this is kind of a framework that is going to be used a lot in the future, in the sense that we can off-board computation. We don't want to do it within the circuit itself. We want the circuit to actually prove that something was performed correctly. Something really important here to take in consideration is these witnesses are not trusted. Everybody can just perform any computation at all and provide a result. So you cannot trust this result. That's why we have to assert the 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 information provided by the witness. We cannot believe the witness by themselves. Perfect. So yeah, that's something regarding compact, and you can see that the way we write compact, it looks pretty much like TypeScript, and that's something that the Midnight team is pushing really hard to actually have this DSL called compact to look like TypeScript. It feels like TypeScript, but it's actually another language called compact. Perfect. So now let's take a look at the Academy. We are in module 2, and with this, we're going to finish what we have for module 2, right? Then we're going to go to module 3, 4, 5, and those who are not aware, this Academy is going to have 8 modules so far, confirmed. Maybe we're going to have more modules in the future, but we're looking at the module 2 right now. In these episodes, we're going to discuss some security considerations when building a smart contract in Midnight. First, they have listed some common vulnerabilities in smart contracts. We're gonna read through them, and explain some important topics. Reentrancy. This is a classic attack pattern. It occurs when a contract calls an external contract or another address, and that external call invokes back into the original contract in the middle of the execution, often in a loop or multiple times. This vulnerability happened in Ethereum and actually was the responsible for the hack that during the DAO hack in Ethereum. And that the way it works, it's you actually call an external contract before updating your state. So that other contract that could be malicious, a hacker, can call back your contract and be able to withdraw a lot of money because your state hasn't been updated yet. So this is why it's called reentrancy. There is good practices to solve this. We're gonna take a look at that later. But this it's solved avoiding these performing external actions before updating our state. In Midnight, we are not sure if this is going to be possible or not. We're talking here about a specific example in Ethereum. In Midnight, we are going to be able to talk with external contracts, but uh, I'm not sure if we're going to have this fallback, meaning the external contract to be able to call back another contract in the process, since everything is proof, right? When you call an external function, that function is going to perform an action, and then when that action is performed, you go back to your contract and keep going on your computation. You're going to have some results from the first from the other contract, but I'm not sure if we're going to be able to have these fallbacks functions, callbacks functions. I'm sorry. Another vulnerability, it's called the integer overflow underflow. This vulnerability arises in languages like older Solidity versions where integers have a fixed size, for example, 256 bits, and don't automatically check for overflow. So they give an example here. For example, you have this uint8 variable x, which the max for the 8-bit it's 255. What happens if you add one value to that? It will overflow. It should go to 0, right? And if you subtract, it will turn all the way around and go back to 255. So if your contract doesn't take account of this overflow, you can see there is a vulnerability over there. Imagine changing a balance from 0 to 255, right? So this is something that you have to take in consideration. And in Midnight, we have this overflow and underflow within Compact. Um, Access control issues. Sometimes the vulnerability is simply not properly restricting who can call certain functions. If a contract forgets to set an owner only requirement where it should, anyone might call an administrative function. So in Midnight, this is uh, much simpler to implement because everything is a proof. To actually implement something, you need a proof. In the future, we're gonna see that in Midnight we can actually declare kind of maintainers of the contract with some specific capabilities. So we need to have good practices to implement those maintainers to not fall into these access control issues and others. There are many more issues that can arise, timestamp dependencies. We don't have time still in Compact. We're going to have that in the future. Denial of service with expensive loops and front running attacks. These loops and denial of service, that's something that was thought really well within Midnight because, as you know, Nights is going to produce this renewable energy called dust to actually execute transactions. But to be able to execute a transaction, you just don't you don't just need dust. You need something else that requires work, which is creating the proof. So you need to create a proof. You need to you need to host this proof server to actually host the proof. If you perform really expensive computations and loops, those proofs are going to take time to generate. So these denial of service attacks are gonna be really hard to implement actually within Midnight. Okay, best practices for secure development. This first one checks effects interactions pattern. It's a pattern that was uh, structured and developed by OpenZeppelin in Ethereum. And they have some libraries, and they are working within Midnight as well to actually create those libraries and good practices. And what it says here, it's what I mentioned before. To not fall into this re-entrancy issue, you should check the effects of your smart contracts, and then perform some interactions, like actually calling an external smart contract. So instead of checking your balance after interacting with an external smart contract, you first update your balance and then talk with an external contract. Use established libraries. So pretty much don't reinvent the wheel. There is many teams that are working on creating these frameworks within libraries. So you should use these libraries because they take in consideration all these possible vulnerabilities. Uh, Proper access control. Well, this is in Midnight. It's gonna be with zero knowledge, with proof. Actually, creating your proof. If you don't, if you create a false proof within the node, when they verify the proof, is gonna fail, and there's no transaction being executed at that moment. Validate inputs and conditions. This again is gonna be creating your proof. Something that I showed before. If you see here within Compact, we have a lot of these assertions. So this is like proving your inputs, proving your outputs. You have to demonstrate that something has been done within Compact, and this translates into a proof. So if that proof doesn't demonstrate these assertions, it's just gonna fail. Uh, Keep it simple. This is really important uh, for both security and for user experience. So the there's a saying, right? The making things simple, it's actually harder than creating really complex standards and frameworks, because making it easy, it's more maintainable, and actually you can see the bugs. So complexity is the enemy of security. Try to write simple and straightforward code. And for user experience, we saw before how to actually perform some off-chain computation and demonstrate that computation within chain. And by doing that, we are actually making our circuits more lightweight. And doing that, the user is going to pay less fees, and the process of creating and demonstrating that proof is going to be way much way faster. And then testing and auditing. I mean, pretty much what we do in Cardano as well, and every blockchain and any software that is being implemented should be tested and audited. Perfect. So now let's talk about hackathons. The hackathons, it's a really nice way to actually learn how to implement within Midnight. And there is different places that you can actually take as reference and learn how to code. You can go to Mesh Discord. We have a channel for helping people out. Within Midnight Discord, there's people collaborating. And right now there is a lot of examples that you can take a look at to learn how to actually implement these applications. For this hackathon right now, they call it Mini DApp Virtual Hackathon. So what they want is the following. Let's take a look here at the hackathon overview. We have heard your feedback. Building fully fledged applications in a short time frame can be overwhelming. That's why this hackathon focuses on polished, lightweight prototypes, just one creative, well executed slice of a dApp. So, what happened before is that people were trying to build these huge applications that demonstrated a lot of features, and sometimes they couldn't managed their time well, and they couldn't finish the project, the 100% of the project. So what they want to do right now within this hackathon is like, okay, don't worry about implementing a fully fledged application. Just focus on something bold, something that it couldn't be considered like a whole application, but maybe some specific feature. Focus on that, polish that, and present that. So this mini hackathon is about that. It's kind of, don't worry about big applications. Just focus on something that you want to build and present it. For example, a beautifully designed UI showcasing how a CK circuit hides a player's position in the game. They don't want to for you to create the whole game, just that specific feature. A confidential job board leveraging private state management. So focus on private management, how to deal with that private and how to selectively disclosure that information. That's it. Just focus on that and make it really nice and polished. A minimalist voting app using anonymous attestations. We are we are leaning into fun. This hackathon is your chance to explore the playful side of privacy. We are looking for submissions that are bold, whimsical, and little unexpected. Maybe it's a beautiful design UI that demonstrates how a CK circuit hides a player position, or a confidential job board that spotlights Midnight's private features. Creativity is the future. Technical implementation is the foundation. With a 2 months timeline, this is important. Before the hackathons, they last 1 month. Now they're gonna last 2 months, and builders will have more time to think deeply about their idea, polish a usable, compelling MVP, engage with others, and refine based on feedback. And here it's the timelines. Duration 2 months. Kickoff it started in June 23rd. The submission deadline is August 18th. Pitches call and the winner announcement. The prices are going to be pretty much the same. The first place 4,000, second place 2,000, and 1,000. So I recommend everybody joining. Uh, this hackathon is the best place. A lot of people ask me, where is the best place, Eric, to start building on Midnight? My answer is these hackathons. You're gonna have a lot of support from the community as more hackathons uh, uh, pass by. There's more developers that learn from others, and they're willing to help you out. So I recommend you guys to just start on building on Midnight, and use the Discord channels to actually ask your questions, and people might jump in and help you guys out. Okay, so now regarding the catalog where we discuss different projects building within the Midnight ecosystem, I wanted to take a look at and actually go through their website of this project called SheFi, a fast growing platform for Web3 educations. So, SheFi is a fast growing platform for Web3 education, has partnered with the Midnight Foundation to bring CK privacy education to thousands of women entering the crypto space. Through SheFi, a structured 8-week bootcamp, participants will explore core Midnight concepts through guided lessons, technical workshops, and social content. This partnership is designed to reach new developers at the very start of their crypto journey. By embedding Midnight content directly into the SheFi curriculum, this initiative will help shape foundational understanding of privacy, CK proof, and secure computation. Participants will also gain access to real world examples, technical demos, and beginner friendly quests showcasing Midnight's capabilities. So let's take a look at their website. So here's SheFi. Um, at SheFi, we believe that the frontier is feminine. Master Web3, reinvent your career, shape the future of Web3. It's going to be in 8 weeks. We can see here there is different cohorts. They are offering now the cohort number 14. And in this cohort, they have included Midnight within their curriculum. So they're going to include different concepts of Midnight. So we can see here that they're pushing really hard to include women that are starting their journey into the crypto space. So really nice project. They're doing a fantastic job. Okay, perfect. So now let's jump into the code. So for those that are first take a look at this, we're working on this repository called Midnight Starter Template under the Mesh organization. And we are taking a look at this folder called API, where we are declaring different functions on how to interact with the Midnight instances and Midnight contract. So now, we in the last episode we finished learning this function called build wallet and wait for funds, where we actually built a wallet instance, waited for it to synchronize, and waited for some funds. And then we returned this wallet resource. Now we are going to learn the other functions that are remaining in this folder, so we can jump into the CLI folder where we actually build our a TUI, a text-based user interface. So let's study this function here now, random bytes. So these random bytes, we are gonna take as input a parameter called length of type number, and the output is gonna be a uint8 array. So now we are gonna call this uint8 array. It's a class that we are importing from. Let me find the. Let me. I'm holding this microphone. The uint array. So we can see here, this is a library that we have in TypeScript to create these new uint8 arrays. So we are passing the length, and then we want to have this uint8 array with those bytes according to the length that we passed. And then we are just filling that's bytes with random bits, right? In that way, using this library called web crypto. And then we are returning just the bytes. So this is a function to create a uint array with random values. We're gonna see where we're gonna use that in the future. This is a function to build a fresh wallet. This is really simple because it's gonna use a function that we have already declared. So let's see. For build a fresh wallet, we're gonna pass the config file that we have already taken a look at here, that we are declaring where the different instances are located. And we are gonna return a wallet resource. So to build a wallet, we are gonna use this function that we just studied from the episode before. Build wallet and wait for funds. We can see here this big function here. Build wallet and wait for funds to actually build a wallet resource that we were passing a seed and a file name. So in this case, we are passing, since we don't have a seed, because if we have a seed, means that we have already created our wallet in the past and we want to actually build it again. But if it's a fresh wallet, it means that we don't have a seed. We want somebody to create that seed and create a wallet. So that's why in this case we are passing a new seed. So how we are going to create that seed? Using this function that we just studied. We're going to create a random bytes passing 32, right? So we're going to create a uint array of length 32 bytes that are going to be filled randomly, and this is going to be our private information, our seed, and we're just going to pass it to hex. That's the parameter that accepts this with wallet for funds. So in that way, we already have our seed. Another function, it's called configure providers. So this function, it's really important, and it's part of one of the parameters that the midnight.js libraries are waiting for, where we declare what are the clients responsible to talk to our different providers. What are going to be these providers? We're going to have the private state provider, we have the public provider, the CK config provider, the proof provider, the wallet provider, and the midnight provider. So we need to have those providers. So now in this function, we're gonna declare those providers. So perfect. This function, we're gonna pass the wallet implementation and we're gonna pass the configs. First, we're gonna create a wallet and a midnight provider. Where this create a wallet and midnight provider is this function here that we declare in the one of the last episodes, where we have this wallet provider, where we declare this coin public key, encryption public key, the balance transaction method, and the submit transaction method. So this is the provider for the wallet and the midnight provider. We already started that using our starting from our wallet. We have this provider because at the end, when we're creating a transaction, we need to actually perform two things. One, it's balance, actually including the fees and completing any coins that that transaction needs from our wallet. And the other important method, it's submitting. We have to send that transaction into the blockchain. Okay, so that function was already created before. That's why uh, we're just calling it here, and that's gonna be our wallet and midnight provider. So at the end of the return of this function, that we'll have our providers, the wallet provider and the midnight provider is gonna be the result of this function here: create wallet and midnight provider. To create the other providers, the midnight.js library um, provide us with some nice client implementations of those providers. So you can see here that for the private state provider, we are going to use this function called level private state provider. This is provided by the midnight.js library. This is a library that it's implemented based on level database, and it's going to be hosted on Node or in our browser. And we declare it this way. We pass the type of the counter private state ID that we declared before, and then we have to pass a name of the store. So it's kind of the name of the database. In this case, we have declared that name on the contract config. If we can see, I'm going to open this config. You can see here that I'm declaring the private state store name, counter private state. For the public data provider, which is the indexer, again, we have a client implementation provided by the midnight.js. So we have this indexer public data provider. We pass the indexer URL and we pass the indexer WebSocket URL. In that way, we have already the implementation of our client to talk with indexer. Really easy. I mean, this has already been implemented for us. For the CK config provider, the same thing. We have this node CK config provider, and we're just going to pass the increment, which is the only circuit that we have in our contract, and the CK config path. So this CK config path, it's where we are hosting that information, right? What is this CK cryptographic material? It's the result from the compilation of our contract. If we remember, in the contract folder, when we compile our contract of the extension .compact, we get this managed folder. And these keys and CKIRs, this is the output, the cryptographic materials that our CK config needs to actually create the proof. So we are saying here, this is where this information is located at. So we have to, in this case, this CK config path. Let's take a look here at the what we have actually included in our config files. We are saying that here the CK config path, it's located at two directories before the actual position. The counter contract, we can see that we have the counter contract under source, under managed, and under counter. So we have this information. So that's how we tell our clients, okay, you have to take a look at this folder to actually find all this cryptographic material necessary for you to create a proof. Excellent. And now for the proof provider. Well, pretty much the same. We are going to use a client implementation function provided by the midnight.js team, and we are just going to pass the config for our proof server. What is this config proof server? Let's take a look. So we have config and we have our proof server. This is the URL where our proof server is located. It could be at localhost or it could be hosted somewhere else. So perfect. Passing that, we have ready the implementation of the client to talk with our proof server. So in that way, we're passing these providers to the implementation within midnight.js. So our code knows how to talk with our private information. It knows how to talk with the indexer. It knows how to get the cryptographic materials to create proof. And it knows how to prove our transactions. It knows how to balance our transactions. And it knows how to submit our transactions. Excellent. It was really straightforward and it's really powerful. We actually now be able to build our transactions using the output of the compiler and interacting with the blockchain using these different providers. Excellent. Now, the last function of this folder, at last, it's safe state. So this is really straightforward. And we have learned before how to stream to string, meaning how to create these a because that's where we learn how to actually save a state of our wallet. The way the wallet works in Midnight is different than the other blockchains, since in within the blockchain everything it's a commitment. So we need to decrypt that commitment using our encryption public key. So we have to scan through the blockchain. And imagine scanning through the blockchain all the time that we create a wallet from zero. It takes a lot of time. So we have a way to actually save the state of our wallet. And when we spin up a new wallet, we can actually use that saved data to synchronize our wallet way much faster. So with this function, what we're doing is creating that checkpoint and saving that information in a file. So we are specifying our wallet and the file name where that information is going to be stored. So what we are doing here is creating that directory, and then you can see here a method of the wallet implementation. It's called serialize state. So we are saying, okay, we have our wallet. I want to serialize the state, so I want to save that information. So I'm going to save this. I'm going to write it under that file. And in the future, I can read that and spin up my wallet from that state on way much faster. So, and then this is just boilerplate to actually log some information when it's finished and end our writer. Perfect. With that, we have all the functions that we need to actually implement a application. We have implemented the UI part, but before getting there, it is recommended to start testing using a text-based user interface, a TUI. So for that, we have this folder called CLI.ts. So this CLI, we're going to use all those functions that we studied before, declare under the API folder, and we're going to use it here on the CLI. So the first function that is going to run within this file, it's called run. So this run is going to be the first function, but we actually call it from other files depending on the configurations that we want to run our application. We studied that before. I'm just going to give a quick refresh since it is important, you can see that we have this function called run on this CLI. But if you look here, we have different configurations to run our instances. For example, standalone, testnet local, testnet remote, te- tested remote, start proof, and tested remote. Let's take a look. For example, standalone. Standalone, what we are doing is creating our config file from that class, from this folder, config file, and then we are creating our Docker environments we're using this library test containers, and we are grabbing those YAML files. So we have this YAML file. For example, let's open this standalone YAML, and we have here the configuration for our nodes. We have the configuration of the indexer, and we have the configuration of the proof server. So with this standalone YAML, using this function of the test containers, we can declare the environment to actually spin up those YAML files as Docker containers. So we have this Docker environment, and then we declare our logger with this function create logger. All this part we were studied on a previous episode. See, if this is new, I recommend to pause this video later on YouTube and go through this process so you can understand how this works. But the important part here that I wanted to mention is here, after declaring this environment, we actually call this function run, which is here in the CLI run. So here we're going to pass the config, the logger, and the Docker environment. So we're going to have these different ways to run our instances, and depending on the mode, we're going to have different environments. For example, standalone, we are declaring this environment using the standalone YAML. In testnet local, you can see here that we just have the config and the logger. We don't have any environment. Why? Because we are not going to be spinning up our own infrastructure. We're going to use somebody else's infrastructure. Testnet remote instances. Testnet remote start. We can see here that we are running this proof server testnet. So in this case, it's a mixture. We want to run some instances hosted by somebody else, but I want to spin up a proof server myself and test it remote. Again, we can see here that we don't have any environments. So in this case, what we're doing is using instances provided by somebody else in the cloud and then calling this run function. So in next episode, what we're going to do is start studying this run function, which is the start or which is the start to actually understand what this file is doing when implementing a TUI. Okay, so that regarding coding. Now I'm gonna open the mics. If anybody wants to jump in, I'm allowing request for anybody that wants to jump in. It's just raising your hands, and I will invite you guys on stage. And at the same time, I'm gonna read through some questions. You can write your questions as well on the chat. Okay, Andrew is saying sorry, need to drop as some other meetings came up. Thanks for hosting, Eric. Okay, Andrew, thank you very much for joining. James, thanks for this walkthrough, Eric. I gotta jump too, but this great stuff. I'm checking with it doesn't say the name here. With tomorrow, we'll keep you in the loop. Talk to you soon. Perfect. Yeah, thank you, Andrew. Thank you, James, for joining. Anybody else has any question regarding this? Okay, there is. I'm gonna take a look here at the. Yeah, somebody's writing a question. I'm gonna see here if somebody brought me a question on Discord as well. Okay, I have a question here. I'm just gonna wait for Lam to actually write his question. Otherwise, I'm gonna answer this other question here. What software we need for scavenger mining? Okay, Lam, that information hasn't been revealed yet. Nevertheless, they mentioned that any computer is going to be capable of solving those puzzles, and you're going to be able to run it on your browser. So there's no software, special software needed to be downloaded. You're going to be able to just open your browser, connect your wallet, and use your CPU to actually solve those puzzles. But this hasn't been confirmed yet. I mean, it's from a Twitter space they mentioned that, but I guess it's gonna be done in that way because they want to be inclusive, right? They don't want to favor any people who has specialized infrastructure. Okay, let's wait. Okay, as Lam is writing his question, I'm gonna just answer. Let's see here. Do we need to manually solve the puzzle or just opening a tab and it's enough? Yeah, Lam, that information hasn't been revealed yet either. But I assume that it's gonna be just an application that you connect your wallet and you just start running. And depending on your CPU, it's gonna be solving that puzzles without any other intervention. For example, you manually. Something that has to be confirmed is how often those puzzles are going to be resolved, and if you want to jump into another puzzle, if you have to manually get into a new puzzle, or it's automatically kind of refreshed to a new puzzle. So yeah, I'm not sure about about that lamp. um, they haven't revealed any information regarding that. Um, Autumn says here, thanks, Eric. Appreciate the overview. I joined late and I made the ecosystem portion, but I'll stay tuned to Midnight socials for those updates. Yeah, thank you, Autumn. Yeah, these sessions are recorded and they're going to be published on YouTube, so you can watch them later on YouTube, and we save all previous sessions. So from session 1, 2, 3, 4 to this one here that it's not a 10, you're gonna be able to rewatch on YouTube. Um, yeah, thanks, Eric. Yeah, sounds good. Yeah, thank you, Autumn. Thank you, Lam. Thank you for your questions. This other question that I just wanted to answer, somebody was writing me here on Discord. It's regarding the hackathon. These hackathons, he mentioned if they need any previous knowledge about how to write applications, uh, and the answer is not really. I mean, you need in the process you're gonna learn how to write. So the main idea of the hackathons, yeah, for sure, it's gaining those prizes, but what you're gonna learn from these hackathons and the network that you're gonna build upon and the knowledge, it's it's really worth it. I would recommend, and then you're gonna you're gonna start learning. Everybody that is starting, I would recommend here in the call. It's John Santi, and I think John, it's a good reference to give support in the sense that how he started getting involved in the ecosystem, how he started writing code. He started as well from zero, starting how to write code. He partnered with teams who helped them out. When you're building an application, not everything is code. There's architecture, there's planning, so there's different features that people can add value on something. So yeah, I would totally recommend joining a team, start working on a hackathon, and participate. No knowledge, no previous knowledge required. And for those that are new, I recommend for you to join a team. There's a lot of people that want to create teams and start working together. So that's the path forward that I would recommend. Okay, John is writing here. Hey Eric, I'm looking for partners for the hackathon, and I would love to speak with anyone interested. Tell them about the Discord channel. Okay, see, John is already opening his arms for new partners. So John is a good example how to he actually build up a partner, a team, and participate on the hackathon. He won the hackathon, so you can see that it's possible, and I would recommend for you guys to do that, and get in touch with John. John is looking for partners, and if you want just to build your own partners, your own teams, John can give examples and knowledge how to do that, and all the knowledge that he has been built during this process. So yeah, well, thank you everybody. This is all for these episodes, and in next episode next week we're gonna jump into this CLI folder. So we're gonna start learning how to write our first TUI and actually build how to first interact with the actual Midnight blockchain. So see you all next week. Bye bye.